Alright, today's topic, the Pythagorean theorem, and the converse of the Pythagorean theorem, really shouldn't be anything majorly new. You're going to use and apply some of your new skills with radicals, but you're also going to be going back and looking at what Pythagorean triples are. I will show you what Euclid's formula is, and then you'll have some problem solving that deals with the Pythagorean theorem. It's going to have some little details that you got to make sure that you're keeping up with. So I'm going to kind of brush through a whole bunch of problems from pages 4 to 7 just to kind of give you a taste of each section, and then you're going to be responsible for going back and finishing these as your classwork. So starting with the first one, we're going to do 1 and 6 in the first section. For number 1, I want to solve for x. Remember, the Pythagorean theorem states that in every right triangle, the sum of the squares of the legs is equal to the square of the hypotenuse. Hypotenuse is always the longest side of a right triangle. So for number 1, I have one leg, x is a leg, and then 24 is my hypotenuse. So I'm going to have to say x squared plus 6 squared equals 24 squared. If you do not show me this basic work, you can use a calculator if you don't know 24 squared. But if I don't see this set up, it's not done. So make sure today that you are showing all of the work necessary. So for this one, x squared plus 36 equals 576. X squared equals 540. And then I'm going to take the square root of both sides. So at this point, you can definitely use the calculator to try to start breaking down 540. You can also use y equals and do 540 divided by x and try to find what whole numbers go into it. I will tell you right now that it is 36 times 15. And if you go to your table of values, you can see it's 36 and 15. Square root of 36 is 6, 15. And I hope some of you are pausing to say, well, isn't it both the positive and the negative value? And technically, yes, and in an equation, it is both positive and negative. But when we're talking about the length of a triangle, it doesn't make sense for us to say the x is positive and negative because we won't have a negative length. We're going to move on to number 6. In this one, I have both legs. I'm looking for the hypotenuse. So I have square root of 6 squared, square root of 15 squared, equals x squared. Make sure you're showing your work. 36 plus 15 is x squared. I just made a mistake. That should just be 6. Sorry. 6 plus 15 is x squared. So 21 equals x squared. So therefore, x equals the square root of 21. All right, Pythagorean triples are just a set of 3 positive integers, and an integer is any number that does not have a fraction or decimal piece. That should be a whole number. An integer technically is a set of whole numbers and their opposites. So a triple, we're looking at positive whole numbers, a, b, and c, that satisfy the equation c squared equals a squared plus b squared. So these are the most common triples that you'll see: 3, 4, 5, 5, 12, 13. So I'm just meaning 5 squared plus 12 squared equals 13 squared. 7 squared plus 24 squared equals 25 squared. And 8 squared plus 15 squared equals 17 squared. Something else to kind of keep in mind is that their ratios, or their scaled up or scaled down versions, also work. So if I doubled 3 and got 6, and I doubled 4, I got 8, then the hypotenuse will be 10, and it does form a right triangle. So for number 1, what you're going to do for these, you'll have more on the practice, is you're going to look at how could I have scaled 3, 4, 5 up. So 15 is smaller than 20, so 15 must align with the 3. So I did times 5, I did 4 times 5, so that must mean I did 5 times 5, so A must be 25. To go for the second one, I did 5. To get to 45, I must have done times 9. So then this is 9 times 3, so this must be 9 times 4, or 36. For this one, I did the hypotenuse 5 times 7. Here's 4 times 7, 28, so C must be 3 times 7. This was a little bit trickier. Think of it like this, 4/3. So I have 1, I have 4/3. What would D be? How could I go, 1 is smaller than 4/3, how could I go from 3 to 1? Divide by 3. 4 divided by 3 is 1 1/3. So then D must be 5/3. Or 1 2/3. Then last but not least, 75. 5 times 15 is 75. So then 3 times 15 is 45. So E must be 4 times 15 or 60. So you can go finish up number 2 a little bit later. We're going to get through all the notes together. At the top of page 5, I have mixed Pythagorean triples. So you're going to have to figure out which one of these triples matches this. So you're going to try to find, how could I go from 5 to 15 or 13 to 15? And then they're mixed. So for this one, you could hopefully notice that 5 times 3 is 15. 3 times 3 is 9. So A must be 4 times 3 or 12. You're going to put the letter A in the triangle so you know you used the first Pythagorean triple. I marked this one off. This one isn't accurate, so you can go ahead and nix that one as well. The converse of the Pythagorean theorem is just the opposite of the Pythagorean theorem, where if we say the square of one side, and really we should say the square of the hypotenuse of a triangle is equal to the sum of the squares of the legs. So this might be good to even clarify. Hypotenuse to the other 2 legs, then the triangle is a right triangle. So you're going backwards. So we know it's a right triangle if the Pythagorean theorem is satisfied. So you take your short sides, 9 squared plus 12 squared. Does it equal 15 squared? I always put that question mark because I don't know for sure. 81 plus 144. Does that equal 225? 225 equals 225. That checks off. So yes, that does make a right triangle. Down at the bottom, Euclid's formula. This is really only meant for honors level students. And I do want you to try it. This can be something you do at the end, but if you are done with your work, you do need to come back and do these. So if m and n are arbitrary pairs of positive integers and m is greater than n, you're going to use this to be able to figure out the triple. If m and n are co-prime, that just means they might not be prime numbers themselves, but they don't have any factors in common other than 1. So 8 and 9 would be co-prime. They are not prime, but the only factors of 8 are 2, 2, 2, and n are 3. So they don't share any factors. And exactly one of them is even. Then the triple formed is primitive, meaning A, B, and C are co-prime. So before you get bogged down in all those verbs and words and whatever, we can just give it a go. So I know that n is 1 and m is 2. I got positive integers and m is greater than n. So to figure out A, I would do m squared, which is 4, minus n squared, which is 1. That's 3. I can figure out B if I'm multiplying them. 2 times 2 times 1, which is 4. And then C is m squared plus n squared, so 4 plus 1. So there's our triple, 3, 4, and 5. And then to go backwards, if I'm given the actual triple, I can figure out what m and n is. So what I did for this is I noticed that A and C are very, very similar. And then I'm probably going to have to do a system of equations because I've got 2 variables. So since they're similar, but one's minus, one's plus, I'm going to be able to eliminate one of those variables. So A is going to be 7. So 7 equals m squared minus n squared. And then I'm going to do C. So this was A. This is C. 25 equals m squared plus n squared. So if I have a system and I can cancel these guys out, then I'm going to add my two systems together. So I have 7 plus 25 is 32. M squared plus m squared is 2m squared. Divide by 2, 16 equals m squared. So 4 equals m. And again, it is positive and negative, but we're only going to use the principal square root because we're talking about positive integers. So then if m is 4, you can go back and substitute anything in. I'm going to use the middle equation. So if m is 4, I know my b is 24. So I have 24 equals 2. n was 4 times n. So I have 8. I'm going to divide by 8. n equals 3. So that's just something that you can go back and try to do those after you've finished everything else. You're going to do all of page 6 on your own. It just follows right along with our classwork. You can definitely use a calculator, but I should see what you're putting in the calculator for all of it. 21 and 22 at the top, again, very similar, follows along with those triples. And then at the bottom, just be careful as you read through these. They ended up being a little bit tougher for some of the track 1 kids than I thought they might be. Pay attention here. They're telling you how fast they're going, and then you know how long they've gone for. You can calculate how long they went, so you're determining the length of your triangles. Remember, in trapezoids have 2 bases, and it's isosceles trapezoid, so that just means those two are going to be the same. For this one, we have 2 right triangles, so maybe it would help to rotate the paper if you needed to see a way to figure out a missing side. And then down here, you are going to have to do some quadratic work. But it's not as bad as you might think. Okay?